Hi everyone, my name is Raghav from the YouTube channel Shutter Authority, and today we'll be looking at creating smoke and fire simulations in EmberGen. EmberGen is a real-time fluid simulations program which runs entirely on the GPU. Let's go ahead and take a look at the UI. This is the viewport where you can see a simulation happening in real time, and this is the node graph where you have all these different nodes which make the simulation happen. When you click on a node, this is where you'll see all the information and the settings relevant to that node. And to navigate in the viewport, if you left click and move your mouse, you're going to orbit around the object. And if you center click and move your mouse, you're going to pan. And if you want to zoom in and out, you can use the scroll wheel. And if you press C, it is automatically going to recenter you to the scene. And if you press space, it pauses the simulation, and R resets the simulation. You can also find the same settings here on the top. Okay, now let's go ahead and look at recreating this simulation from scratch. Before we start, let's take a closer look. What's happening here is there is an initial burst which is going down and colliding with the floor, and that is spreading outward as the rocket goes upwards. I'm going to select all of these nodes and move them out, and I'm going to select this link and press delete. Now I can right click and create a new simulation node and connect it to the volume node. If I drag out of the emitter, I can create a new emitter, and if I drag out from shapes, it lets me create a shape, and I'll select shape primitive. So this is going to be emitting all the flames. So I'm going to change this to a capsule and reduce the length to 2 meters and the radius to 0.65. If you press show bounds, you're going to see the space where the simulation is happening. Currently it's really small, so we're going to go into the simulation settings and make it bigger. I'll make it 320 by 320 by 192, and then when I hit apply, it applies the new size. Now let's scroll down and change a few more settings. We'll change the advection method to BFECC, and we scroll down to combustion, and I'll decrease the combustion fuel loss to 20. So when you want to understand what a certain parameter does, you can just put your cursor there, and it says for each unit of fuel that burns, how much fuel should disappear per frame. So lowering this number is going to have your flames last a little bit longer. And then extinction smoke gain, I'm going to increase this to 95 so that my smoke stays on screen a little bit longer. Now we'll scroll down to force and increase the buoyancy to 250. We'll also enable the blocking Z minus ground. This will allow the generated smoke to interact with the floor. Now we'll go down and reduce the shredding intensity to 0. Now press R to reset and spacebar to start the simulation. Now let's go ahead and add a force to the emitter. So you drag out of it and select force line. And here I want to animate the push strength. If you hold down Alt, you can see all the emitters and the forces in the scene. So what this parameter does is it pushes your simulation in the direction of the line, and if we give it a negative number, it's going to go downwards. Hit the floor and then get wider. We press this button to start the keyframes. So these are all the ones from the previous nodes. The keyframes that we'll be creating now will go below. And then right click here and I'll enter -15. Go forward a few frames, enter, -500 and -250. Now let's look at what happens. So it starts, it goes downwards, hits the floor, and then starts to widen. Okay, next what I want to do is I want to animate this shape to be going upwards. So we select this and press this button here for the position, and now on the Z axis we're going to go to about frame 80, right click and -2, and we'll go forwards to 260 and 20. Let's see what happens. It starts and it starts to rise up. Perfect, that's going really good. Now let's animate a few of the emitter settings. Firstly, we'll animate the fuel rate. So you press the button to create keyframes for the fuel rate. Right click here, enter 0 and press enter, and then go to frame 60, right click and give it a value of 100. We'll also animate the additional pressure rate. Right click here, we'll leave that at 0, and then right click again and change that to 250 and add one more and make it 0 again. We want to reduce the pressure random intensity to 0. That's looking quite nice. Now let's go ahead and add a force to the simulation itself. So you drag out of there, create a force line. And in this case, we're going to drop the push strength to 0. And here we'll animate the repel strength. So press this button here, scroll down, and at the first frame, we want it to be 0. And then around frame 20, right click and add a value of 2. And then we go forwards and give it a value of 1. Now let's reset the simulation and press the spacebar. So now it is repelling on this axis and pushing the simulation outwards and making it a little bit flatter. Okay, the next thing is to add a collider. So we will drag from here, collider, and then from shape, we will select shape mesh. And you might now notice that it added in the rocket. This is because this has already been imported into this node from the previous template. So if you wanted to change this, you could just go here, say open mesh file, and select your 3D model and it should appear here. Okay, let's move this a little bit up like this. And now we are going to animate this to go up with the flames. So we will select it and press on this button for the position keyframes. And on Z at about 80 frames, we right click and give it a keyframe. And then we go to 260 and then give it about 23. Now let's see how it looks. Nice, this is looking pretty impressive. Now let's go ahead and see how we can render this out. Head over to the capture node and you press this plus button. And now you can press none and select render combined. Or you can select any of these other render passes, which can be very useful if you're going to be compositing this. But we're just going to select render combined. Now you drag from here and then say export image. And now you connect G to G, blue to blue, and alpha to alpha. And here you can check export sequence. So let's render this out at 2K. So I'm going to enter 2048 by 2048. And now I'm going to select the folder where I want this to render. So I'm going to say render and rocket. And we can press preview and you can select which camera you want. And if you want to mess with the camera settings, you can go to the camera node and change all of this to suit your scene. Now you can re-watch your simulation here through the preview window. There are also lots of settings in the volume node, so you have a lot of control over how it renders. Another cool thing is gradients. So you can plug a color gradient into the fire color and select the colors you want to have in your gradient. You can also tweak the light settings here by going into the light node. Currently the options available for lights might seem quite limited, but the guys at JangaFX have been working on a whole bunch of features that would give it a lot more options for better lighting and rendering. Once we're happy with all of that, you select how many frames you want the sequence to be. I want mine to be about 250 frames and then press export sequence. Alright, the render at 2K was done in about 1 minute and I went ahead and composited this onto some live action footage in Adobe After Effects. Soon we'll also be able to import animated cameras and also animated meshes, which can be used as emitters, and that would really lead to a whole new range of possibilities in EmberGen. I think this is really changing the way we make volumetric simulations, and the best part is that it's fully GPU accelerated, so it's really fast. So go ahead and download EmberGen and give it a try. I'm very excited to see what all we'll be able to do with this program in the future. Alright everyone, I hope you enjoyed this tutorial. Make sure to subscribe to the NVIDIA Studio YouTube channel and have fun playing with EmberGen. Bye!